Hello everybody, I'd like to welcome you to our 26th video in the pre-algebra playlist, and in this video we're going to go over the concept of greatest common factor. Let's first do a few more examples of prime factorization. Now we learned how to do prime factorization in the last video, but it doesn't hurt if we practice a bit more. In this case, let's say I have some numbers such as 621, and I want to figure out the prime factorization for that number. The first thing that I need to do is figure out what is the smallest prime factor for the number 621. In this case, I know that the answer cannot be the number 2 because 621 divided by 2 will give me a decimal answer. Now, if I try the number 3, that does work. Now, how do I know that that does work? Well, if we refer back to our divisibility rules, I know that 621 is evenly divisible by the number 3 because 6 plus 2 plus 1 is equal to 9, and we know that 9 is divisible by the number 3. So what I do now is I draw a little branch, and on one side of the branch I have the prime factor 3, and on the other side I have the number 207. I know that 207 divided by 2 will not give me a whole number answer. Therefore, 2 is not a factor of 207. But 3 is indeed a factor of 207. I know that this will give me a whole number answer because the sum of the digits of 207 will give me a number that is divisible by the number 3. So 207 divided by 3 gives me 69. So on one branch now I have the number 3, which is the smallest prime factor of the number 207, and on the other branch I have the number 69. Can I do more work to the number 69 over here? Yes. The reason being that the smallest prime factor for the number 69 is again 3, because when I do 69 divided by 3, I get 23. And since 3 is a prime number and 23 is a prime number, I have two prime numbers on both sides of the branch. So I am done over here. Now all I really need to do is write these prime numbers over here as a product. So my final answer is 3 times 3 times 3 times 23. Another way of writing this over here is to use exponents and write this like this over here. So the prime factorization for the number 621 is 3 to the power of 3 times 23. In this example, let's say I want to figure out the prime factorization for the number 125. What I first need to do is figure out what is the smallest prime factor for the number 125. In this case, 125 divided by 2 doesn't work. 125 divided by 3 doesn't work, but 125 divided by 5 does indeed work out. This is because when I do 125 divided by 5, I get 25. Now I draw a little branch, and on one side I write the smallest prime factor, and on the other side I write the answer that I got, which is 25. The smallest prime factor for the number 25 is again the number 5. So now I break apart 25 into two branches, and on one branch I have the smallest prime factor, which is the number 5, and on the other branch I have the answer I get when I do 25 divided by 5, which again is 5. All there is left for me to do now is to multiply all of these primes together. This right here can be better represented using exponents by simply stating 5 to the power of 3. So the prime factorization for the number 125 is 5 to the power of 3. Now let's go over the concept of greatest common factor. Greatest common factor is often referred to as the GCF. And the largest factor that is common between two or more numbers or expressions is known as the greatest common factor of those numbers or expressions. So now let's do a few examples involving greatest common factor so you get a better understanding of what they are. In our first example, let's say I want to figure out what is the greatest common factor between the number 60 and 100. So one of the quickest way is to figure out the prime factorization for both of these numbers, and then from there I can figure out the greatest common factor between these two numbers. So first let's figure out the prime factorization for the number 60. I know that the smallest prime factor for the number 60 will be 2. So on one branch I have the number 2, and on the other branch I have the number 30. Then I move on to this number over here, which is 30. The smallest prime factor for the number 30 is again 2. Now I can break 30 up into two branches and have 2 on one side and 15 on the other side. Then lastly, I can break apart 15 into prime factors. The smallest prime factor for the number 15 is the number 3. So I can break apart 15 into two branches, and on one branch I can have the number 3, and on the other branch I can have the number 5. So now I can multiply all of the prime factors together, and I get 2 times 2 times 3 times 5, which is better represented as 2 to the power of 2 times 3 times 5. Let's now do the prime factorization for the number 100. I know that the smallest prime factor for the number 100 is the number 2. Now I break apart 100 into two branches. On one branch I have the number 2, and on the other branch I have the number 50. The smallest prime factor for the number 50 is again the number 2. Now I break apart 50 into two branches, and on one branch I have the number 2, and on the other branch I have the number 25. The smallest prime factor for the number 25 is the number 5. So when I break apart 25 into two branches, I'll have the number 5 on both branches. Now I have prime numbers on all of the branches, and all I really need to do now is multiply all of them together to give me 2 times 2 times 5 times 5. This is better represented using exponents as 2 to the power of 2 times 5 to the power of 2. Now the last step that is left for me to do in order to figure out what is the greatest common factor between 60 and 100 is to figure out what prime factors are common between both of these prime factorizations. I know that I have two 2's over here as well as two 2's over here. Also, I have two 5's over here and one 5 over here. So in common, I have one 5 between the two of them. The number 3 is not a common prime factor between these two prime factorizations. So the numbers that are common between these two prime factorizations are the two 2's over here and the two 2's over here, as well as the 1 5 over here and the 1 5 over here. So the greatest common factor between 60 and 100 can be represented as a product of 2 times 2 times 5. This can be better represented using exponents as 2 to the power of 2 times 5. And when I simplify 2 to the power of 2 times 5, I first simplify 2 to the power of 2, which will give me 4, and 4 times 5 will give me a 20. Therefore, the greatest common factor between 60 and 100 is the number 20. Let's say in this example over here, I have what is the greatest common factor, or the GCF, between the numbers 21 and 70. In order to figure out the GCF between these two numbers, I first need to do the prime factorizations of both of these numbers. So let's now do the prime factorization for the number 21. The smallest prime factor of the number 21 is the number 3. So on one branch I have the number 3, and on the other branch I have the number 7. This right here is my answer for the prime factorization for 21, because I have prime numbers on all of my branches. So the prime factorization for 21 is simply 3 times 7. Now let's do the prime factorization for the number 70. The smallest prime factor for the number 70 is the number 5. This is because when I do 70 divided by 5, I get the whole number answer of 14. So on one branch I have the number 5, and on the other branch I have the number 14. The smallest prime factor for the number 14 is the number 2. When I do 14 divided by 2, I get the number 7. So on one branch I have the number 2, and on the other branch I have the number 7. Therefore, the prime factorization for the number 70 is 5 times 2 times 7. Over here is the prime factorization for 70, and over here is the prime factorization for the number 21. Now, what are the common factors between these two products? Well, I have a 3 over here, but I don't have any 3's over here. I have a 2 over here and a 5 over here, but I don't have any 2's or 5's over here. The only thing in common that I have is the 1 7 over here and the 1 7 over here. Therefore, the greatest common factor between the numbers 21 and 70 is the number 7. In this example over here, I have what is the greatest common factor, or the GCF, of 4a to the power of 2 times b to the power of 3 and 2 times a to the power of 3 times b to the power of 2. The first thing that we can do is figure out what is the greatest common factor between the numbers. The first coefficient over here is the number 4, and the second coefficient over here is the number 2. So when I do the prime factorization for the number 4, I simply get 2 times 2. And since 2 is already a prime number, I can't really do a prime factorization for 2. Therefore, the greatest common factor between 4 and 2 is simply 2. The next thing that I need to figure out is what is the greatest common factor between the a's. Well, I have two a's being multiplied with one another in the first expression, because a to the power of 2 is the same thing as saying a times a. In the second expression, I have three a's that are being multiplied with one another. So the most number of a's that I have in common between these two rows over here is 2. So I have two a's that are being multiplied with one another. That is the common ground between these two expressions. So I can further write my greatest common factor as 2 times a times a. Now I need to move on to the b's over here. I have three b's that are being multiplied with one another in the first term over here. In the second term, I have two b's that are being multiplied with one another, because that is the meaning of b to the power of 2. So how many b's do I have in common between this first row over here and this second row over here? Well, I have 3 b's on the top and 2 b's on the bottom. So the most number of b's that I have in common between these two expressions are 2. Therefore, I can further expand the greatest common factor by including the multiplication of these two b's into the already known greatest common factor of 2 times a times a. So this right here is the greatest common factor between the expression 4a to the power of 2 times b to the power of 3 and 2 times a to the power of 3 times b to the power of 2. I can better rewrite this greatest common factor using exponents as 2 times a to the power of 2 times b to the power of 2. So that's it for this video. I hope you learned a lot from it. I hope you keep on working hard, and I'll see you in the next video.